Ever wonder how a computer tackles a problem that seems, impossibly huge? Well, it's not magic, and they're not really thinking at all. It all comes down to a really clear, powerful blueprint. So let's pull back the curtain and figure out how we tell these amazing machines exactly what to do. This quote? It absolutely nails it. See, computer science isn't just about tapping away at a keyboard writing code. It's about being an architect of ideas. It's the art of taking a messy, complicated real-world problem and creating a clean, elegant model, a plan, that a machine can follow perfectly. Just try to wrap your head around the Indian Railway network for a second. We're talking thousands of trains, millions of people, all trying to book tickets at the same time from every corner of the country. I mean, what a logistical nightmare, right? This used to be an overwhelmingly human task. And now, we just book a ticket on our phones, without a second thought. And it all works because someone created a crystal clear, logical plan for a computer to follow. So here's our game plan for how we're going to break this all down. First, what's a computer's real job? Then we'll talk about the algorithm, our recipe. We'll look at the 4 steps to get to a solution, how we control the logic, and finally, why this is a whole mindset that goes way beyond just programming. All right, first things first, let's get one thing totally straight about the relationship we have with our machines. Okay, so here's the big secret. Computers, they're not smart. They are incredibly powerful, unbelievably fast, and extremely obedient. But they only do exactly what we tell them to do. Their real power is executing our instructions flawlessly billions of times a second. We're the brains of the operation, they're the brawn. Which naturally leads us to the real star of the show, that set of instructions we give the computer. It's a fancy-sounding word, algorithm, but all it really is a plan. A recipe, actually. That's the best analogy. If you have a good recipe with clear steps and exact measurements, pretty much anyone can make a delicious cake, right? Well, an algorithm is just a perfect, foolproof recipe for a computer. But hey, not all recipes are created equal, are they? A good algorithm has a few key ingredients. The steps have to be precise, no pinch of this or dash of that. Every step has to lead to one and only one outcome. It also has to, end. An infinite cake recipe is pretty useless. And of course, you need your ingredients, the input, and you need to get your finished cake, the output. Okay, so how do we actually write one of these perfect recipes? Well, it's not just a random flash of inspiration. There's a process, a 4-step blueprint, really. Let's use another analogy. Imagine you're a car mechanic, and a car comes in making a weird noise. You don't just start ripping the engine apart, do you? No. First you listen, you poke around, you analyze the problem, then you develop a plan for how you're going to fix it. That's your algorithm. Then you pick up the tools and do the work. That's the coding part. And finally, you take it for a test drive to make sure the noise is gone. That's testing and debugging. Let's make this super concrete. Before a programmer writes a single line of actual code, they'll often sketch out the plan using something called pseudocode. It's exactly what it sounds like, fake code. It's not for the computer, it's for us humans, just to make sure the logic is solid. So for finding a square of a number, the plan is dead simple. Get a number, multiply it by itself, and then show the answer. That's it. Or if you're a more visual thinker, you can map out the exact same logic with a flowchart. It's basically a diagram of the whole process. You use different shapes for different jobs, one for starting and ending, another for getting input or showing an output, a rectangle for doing the actual work, and a diamond shape for making decisions, which is super important as we'll see in just a minute. The arrows just connect everything and show you the path. And this is a really, really important idea to get. The algorithm, that plan we just made, whether it's pseudocode or a flowchart, that's the architect's blueprint. The code is the actual building you construct from that blueprint. And you'd never try to build a skyscraper without a solid blueprint, right? Same deal here. A great plan is the foundation for great software. Okay, but let's be real. Most problems aren't a straight line from A to B to C. Life's more complicated than that, so our algorithms need to be able to handle twists and turns. They need to be dynamic. The most basic path is just a sequence. Do this, then do that, then do the next thing. That's exactly what our number squaring example did. It's clean, simple, and straightforward. But what happens when you get to a fork in the road? That's where selection comes in. This is all about making choices. Think of it like plain old if, then, else logic. If it's raining, then I'll take an umbrella. Else, I'll just wear sunglasses. The program can basically choose its own adventure based on the situation. And we do this all the time without even thinking about it. Your lamp doesn't work. First question, is it plugged in? If the answer is no, well, you plug it in, problem solved. But if it is plugged in, you move on to the next question. Is the bulb burned out? See? It's a decision tree. And this is precisely how a computer navigates complex choices, by breaking them into a series of simple yes or no questions.
And finally, what if you need to do the same thing over and over again? It'd be exhausting to write out clap 1,000 times. Instead, we use repetition, or what programmers call a loop. It's like saying, clap 5 times. The algorithm just repeats a task while a certain condition is true. This is what makes computers so incredibly efficient.
All right, let's zoom out for a second, because what we've been talking about here, it's so much bigger than just writing code. The real magic behind all the amazing software we use isn't some secret, complicated language. Nope, it's this way of thinking, this structured, step-by-step, methodical approach. Taking a huge, scary problem and just breaking it down into tiny, manageable steps, simple decisions, and efficient loops. That's the secret sauce. So let's just quickly recap the big ideas. Number 1, computers aren't geniuses. They just need a perfect plan, an algorithm. Number 2, creating a solution is a 4-step dance. Analyze, plan, code, test. 3, the most powerful plans use logic to make choices and repeat tasks. And 4, most importantly, this structured way of thinking is a superpower you can use for almost anything. And that's really what I want to leave you with. This whole framework, it's not just for tech people. It's a blueprint for thinking. It doesn't matter if you're planning a project, learning a new skill, or just trying to fix something around the house. This process of analyzing, planning, doing, and testing can bring order to any kind of chaos. So here's my question for you. What complex problem in your life could this blueprint help you solve?